who's heard of the Nymi wristband here? Awesome. Our PR people are doing a good job. So this is the Nymi wristband. Actually, this was it about a year ago. So a quick little history. Bionym is about 3 years old, and we conceived of the Nymi, which I'll talk a little bit about a year ago. And we quickly whipped this up as our first alpha prototype to prove that we could do what we said we could do, which I'll describe in a second. So my part of this talk is going to be as short as possible because you really want to listen to Wesley, who has the interesting stuff to say. And I apologize, my slides look really kind of marketing. I just pulled them from my pitch deck just so I have something to throw out there. But Wesley's going to have some really interesting stuff to say. So the problem that we deal with the Nymi is about identity. So the world we live in today, you have to prove your identity so many times, from passwords, PINs, physical keys, key cards, all of those things we view as ways to prove your identity. And so what, we thought, there's so many points of friction, and we actually had some key technology that we could use to essentially make all of this friction go away. Next slide. So, no? Yeah, okay. So the concept was really, well, what if you could wear something that always knew who you are, just naturally, and could then seamlessly in the background communicate your identity to everything around you, could do so securely, protect your privacy at the same time, and all of those points of friction throughout your day, proving your identity, just melt away completely. And so that was what we realized we could do with our technology. And our core technology that we have is the ability to biometrically recognize people based on their cardiac rhythm. So your ECG is a unique biometric, like a fingerprint. And it took a couple of years for us to sort of connect the dots, and we thought, well, if we put this in a wearable form factor, and we have a wearable authenticator, and then it communicates to the outside world, essentially we could solve so many problems of today, but not just that. What if everything around you, all your technology, all the services you interact with, could just automatically know who you are, know your preferences? How would they behave differently, right? How would service in a retail environment, or how could hospitality be completely different if they automatically know your preferences, your favorite drinks, your favorite songs, stuff like that? So it's not just about security, it really is about identity and how you give that sort of to the entire world. So I'm actually going to skip over the video because, that's the wrong way. We totally rehearsed this, yeah. So what the Nymi is a wristband. So this here was the Nymi a year ago. I'm going to put this down. Anybody can come and take a look, but I'm not going to pass around because it's a piece of history and we only have one of those. So this is the Nymi today. It's not quite done yet, but we're getting pretty close. So we shrunk it down. We made it pretty easy to wear. And so what it is at its core, it's got biometric technology, which we call Heart ID. So you put it on, it knows who you are based on your cardiac rhythm, and it only works for you. You lose it, you take it off, someone else uses it, it doesn't work for them. Bluetooth LE, you'll hear this, of course, a lot with wearable devices. Bluetooth is what enables really low power communication with an ecosystem of devices. We do proximity detection using Bluetooth Low Energy. So how far away are you from something, right? So if you have your identity plus how far away you are, you can now perhaps unlock something based on, say, you're within a couple of inches. Hardware-based security. So, it's really important that this is not something that can be hacked with malware or anything that, has secure boot on this. I don't know if you're going to talk about that. Not really. Okay, never mind. You can ask about that later. Motion sensing. So how do you indicate what you want to do with your identity? Do you want to open the front door of your car? Do you want to open the trunk of your car? So simple motion gestures indicate what you want to do. And all of this is wrapped in a simple API, so anybody can write applications that use the Nymi. So now the thing is, to us, the wearable hardware is really just a vehicle to put persistent identity on people's bodies. So the interesting thing comes the ecosystem. This is not like just a fitness tracker that this is all it does and maybe talks with your phone to, you know, transmit your information. This is the center of an ecosystem that can communicate to anything that's Bluetooth enabled, and those devices can do whatever they want to do with what we provide with, through the API. That presents a lot of really interesting challenges. The ecosystem that we're talking about only partially exists. We're conceiving what some of it is. We're kind of at the center of it, and then we have to develop all of this. So I should mention, so Bionym a year ago was 4 people. We are now 27, so I should say we're continually hiring. We expect to be 50 before the end of the year. So now that I give you an idea of what it is that we're doing, I want to let Wesley talk about the more interesting stuff, to dive in a little bit and say what are the development challenges that we encounter in making this happen.
Yeah, so I want to give you guys a sense of some of the problems that we're working on and something of a flavor of what it is to develop for wearables and how Bionym is taking core ideas about developing software, but bringing those into the world of wearables, where we need some adaptation to deal with the fact that we're talking about custom hardware. So the summary of what I'm talking about is integration testing. So I have to tell you what we are integrating. And I don't know what people's reaction is when they hear testing in the software development cycle, but I find that for a software engineer, testing is a really interesting problem, and especially in the case of where you really are trying to isolate precisely some execution path, some singular piece of logic. And you want to isolate that as tightly as possible so you know that it's really doing its job, so you can trust it when it goes out in the wild, when it's outside of your control, that it's going to keep doing the thing that you want. So I have a sketch here of what we are integrating, and I want to indicate the stack of things that we're building. So Karl has told you about the wristband that is Nymi, which is our custom hardware, which we're running firmware that drives that device. But as Karl was hinting about, the Nymi functions within an ecosystem of applications that while we are contributing some of these applications, right, this will only be a really living ecosystem if all of the world is building applications with us, right? And so one of our core products is an SDK that lets you integrate the Nymi into your applications. So our expression for an application that uses a Nymi is an NED, a Nymi-enabled device. And the product that we're building doesn't stop at the hardware and the firmware on that Nymi, but we also need to be giving you an API, a communication library that'll let you integrate Nymi into your applications. So what I'm sketching here is we've got Nymi at the top, which has, it has some sensors, ECG, IMU to capture gestures, which is how users give input to the Nymi, and then it's communicating over this Bluetooth low energy protocol to some other Bluetooth low energy radio, and that's going to be abstracted to applications via the Nymi communication library. So I've got a couple acronyms here, but I hope you'll tolerate them. That NED are Nymi applications, and then we have this Nymi communication library, right? So if you're writing an NED, so I've sketched here some code of what it might look like if you're trying to interact with a Nymi. And so the model that we have will be familiar to anyone that has used a Bluetooth device before, right? When you have a Bluetooth device that wants to talk to an application, there is some process by which you need to authorize the device to speak with a particular application. And this is because when devices meet applications, they don't know each other, and you need to do some work to make this arbitrary Bluetooth radio be the particular Bluetooth radio that your application talks to, right? So the framework by which a Nymi and a Nymi application and NAD come into contact is something that's defined in the communication library. But this interaction is something that works through software that is both within the communication library, which is on some host, and also through the firmware that's on the Nymi. So in order for us to know that this code is working, we need to be exercising code on both sides of the divide. So this is a problem. This is a problem for engineers for the following reason. right? So we have to talk, but to name the problem, I have to tell you something just a little bit about how a Nymi and an NAD come into contact with one another, which is that you need some user interaction to put the Nymi into a mode that will allow it to discover applications that are listening. And this will be familiar to everyone that's used Bluetooth before, right? There is some pairing stage where you put your device into some discoverable mode, right? But that initiation requires user interaction with the physical Nymi, right? With our piece of hardware. And throughout that process, you need to be collecting user input. Right? The user needs to be acting to confirm that the Nymi in question, this particular piece of hardware, is indeed the one communicating with the application that you want. So we might like to write some kind of, you might call these like verification tests, right? The kinds of scripts that define when each of the components of the system are put into particular modes, do you see the results that you have in mind, right? But so the difficulty that I have been meaning to sketch is that while the Nymi communication library that we're building is a piece of software, which is easily scripted by software, the Nymi itself, which is a piece of hardware, is not something that you immediately have control from a software environment, which makes the problem of exercising all these code paths difficult, because this means right now you need an operator of the Nymi to work through all of this code, right? So that when you're trying to test if this thing is working, you need to actually be acting as the user with the Nymi. You need to be interacting with it as a user, and this is a time-consuming process, right? And you can imagine that these verification procedures, right, there's a lot of things that we're asking the Nymi to do, and there's a lot of correctness conditions for the software. And so these scripts will accumulate over the process of development, and only if we can automate them entirely do we have a process that is reproducible, do we have a process that we can really create a product that is doing what we want, right? So what am I sketching in this slide here? The important point is the font is small, but there's an interaction between both the NCL and the Nymi. And right now, out of the box, as developers, when we're building this hardware, we don't have a means to programmatically initiate operations on the Nymi itself. So here's a slide of what a Nymi alpha board looks like in the lab, right? What's sitting on our desks. And what I want to say to you here is, what is a Nymi to a developer? What kind of interface do we have to this device, right? So this board right here represents a Nymi exploded. It has all of the components of a Nymi. It will operate as a Nymi, but it also has the kind of developer interfaces that we have as developers that you wouldn't have in a consumer product. So I'm not sure how much hardware hacking people have done in the audience, but there are a couple of different things that are hanging off of this board. The first USB coming in here, that's just power, but these red squares here, these are our serial interfaces that are able to collect data back from the board, right? This is what lets you emulate a terminal to be able to inspect the inner workings of the device. Meanwhile, if you see this blue box here in the ribbon cable coming in, that's one of the programmers, and here's another programmer that lets us actually be setting the firmware on the device itself. So what do I want to sketch with this is, even though we're working on hardware, you can get down to a fairly tight development cycle, the same kind of thing that you would have on your desktop, right? So people that are writing code on your desktop, you're used to compiling, running, looking at the output of a terminal, right? We can script all of that throughout our development cycle because we're just deploying, collecting from the circuit board. But what we don't have out of the box is a way of initiating these user operations. So I said, like the user operations of the Nymi, a user communicates to a Nymi via gestures, right? And so there's a motion sensor on the Nymi that is detecting how the user is, if you're tapping the Nymi. This is one of the gestures that we use to initiate operations. And so how do we get that to work? Programmatically? So this is actually an important piece that we had to solve for ourselves to be able to do this complete automation. So has anyone in the audience worked with Thrift before? One hand up, that's cool. What I've sketched here is an interface. So Thrift is an RPC library, and I'll get back to that, why that's important for us in a minute. But I'm sketching here a software interface that is all of the operations that a Nymi provides, and all of the operations that you need to execute throughout the course of development, all of the operations you might need to execute throughout any kind of interaction with a Nymi, right? And so this is the first piece of creating a software side to the Nymi. But we need to be able to execute. This is part of the scaffolding we've had to create for this programmatic initiation. The other half is the fact, well, we've got this serial port communication with the Nymi itself, and this is really the heart of how we're able to initiate operations on the device. So the firmware that we're running in development will be a slightly modified firmware, which is not what we'll be running in production, but we have some debug functionality running in the firmware, listening on the serial port, listening for operations, which allows us to initiate some operations from the software side. Right? And so the model that we've come up with is we've created a Nymi daemon, is a piece of software that acts as a software side interface to drive the Nymi as a user. So what am I trying to draw here? The original picture I drew, I had Nymi speaking to NED through a BLE interface, right? Whereas now in test, we have a side channel where an NED is able to interact directly with the Nymi as a user. And this allows us to close the loop and execute all paths to complete these flows that I was mentioning earlier, right? These interactions where a Nymi and an NCL a Nymi and an NED are meeting and they need to provision one another. They need to, recognize each other and create this long-standing link. But so what am I trying to sketch here? And I'm coming to the close of this architecture, but one of the interesting things that this shows is this Nymi daemon, this piece of software that is a crucial piece of our development process, a crucial tool for us in getting control of our Nymi, getting control of our hardware, getting the kind of verification of the Nymi. This is software that never gets out the door. This is software that will never ship because it's not a piece of production. And I think that this shows another side of the nature of developing software, which is software begets software, right? And I'm sure everyone has this experience in some way or another, right? When we build software, all of the construction of software is mediated by other software. We use version control, we use text editors, we use the operating system itself as our interface into these things. But I intend to give you a demonstration of how that plays out in the wearable space and how we've had to work out we've had to create some new pieces in order to carry out the standard exercises of software development in this case of wearables. So that concludes my talk. I wanted to give you this sense about some details on the technical side of our operation and what does it mean to be a developer and what are we doing. But I look very much forward to speaking with all of you in detail after this talk. So thanks so much for your attention.
Sorry, you guys have any questions? There?
How long does it take to read ECG of a person?
Maybe I'll let Karl take some.
How long does it take to read an ECG?
To do the biometric authentication, it varies for people, but it's typically about 2 to 4 seconds.
And is it waterproof?
Yeah, so it has an IPX rating, if you know what those mean. I think it's around 4 to 5, but we're actually looking to improve that, where you can go 3 meters underwater. We think we can achieve that.
I'm really fascinated about the Bluetooth connection, and is there a need for some kind of encrypted communication between me and whatever it is? Is that a lot of overhead?
So any communication that Nymi has with any Nymi-enabled application is done over an encrypted channel. And part of the process by which Nymis and applications discover each other is creating this infrastructure to be able to do these secure communications. So no communication, no content is ever sent in an insecure manner. This creates a certain amount of protocol overhead that in your first interaction you need to set this up. However, there are forms of encryption like block ciphers, like AES, that don't create increased payload, right? So that you're not losing bits on the channel while still getting
guys went through the Next Founders program. I was wondering if you would recommend it and if it was instrumental to your success.
We probably want to take some of that discussion offline because it's a little bit specific, but I mean, it's certainly an interesting program. We kind of were in it rather late, so we went through a very significant pivot where we were only a software company and then we switched to be hardware as well, and that happened prior to us being in that program. So it's interesting. It's sort of a condensed business education for people with technical backgrounds. So I can give you more details, but it was a unique experience.
Does your SDK allow for input devices that speak to computers? So that act as an intermediary to, say, allow a Bluetooth keyboard to speak to a Macintosh?
Sorry, I'm not sure how a Bluetooth keyboard would speak to a Macintosh through our
Oh,
software.
no, not through it, but to
Right.
authenticate one to the other.
I see. As written, the protocols are just letting you interface with it, right? So the idea is to make interactions with Nymis as seamless as possible. But the protocols themselves, we are not as yet opening them up to be used for other kinds of. They're not general purpose protocols. They are tailored to the case of the Nymi. So they're not in the shape that you could funnel other traffic over top of.
No, I wasn't thinking about it. It was just that it would identify the two things to each other. I'm not thinking specific keyboard is just an example.
Right.
So just think in the long term, that you have wearable devices that are providing input, if
Right.
you can identify that specific input to whatever you're sending it to, that would be useful.
It's actually an interesting concept because a lot of the protocols we're creating are sort of solving some of the general purpose problems. The specific implementation is for what we're, for the purpose of the wearable to the other devices. But we're open sourcing a lot of that, being very transparent with what that is, so perhaps it'll be repurposed, repackaged for that purpose.
What kind of outside of current testing that you will award? In specific situations, where are you testing it?
Every kind of situation. So I mean, we collect EC2 data for the biometric authentication from over 1,000 people. We're going through a new round of data collection right now in different scenarios for the biometric authentication. For the other part, which is sort of talking to different devices, a big thing is compatibility. And so we're just sort of in the early stages of that, of having lots of sort of testing out the ecosystem of devices. You would think Bluetooth is standard, it would just work. It doesn't. You do have to test for compatibility.
All right. Okay, last question.
That was actually kind of where I was going. What challenges are you having with Bluetooth? I know that when I go into my car with my phone, it takes 30, 40 seconds to sometimes connect. What challenges are you having with Bluetooth, and do you see that as the standard to use going forward?
So first of all, I would say that Bluetooth 4.0 is better. Chances are, I don't think you're using Bluetooth 4.0. So sometimes some chips are simply better than others. Unfortunately, we are somewhat limited. We know we're not creating our own Bluetooth chip. But the other part of that is that these chips they have programmable stacks where you can actually affect how the communication is sort of timed and implemented. And so our job is just to make it really seamless. So we're putting a lot of effort into that.
Thank you, Karl and Wes.